today we are going to just wind up the chapter 2 of class 10, that is acid, bases and salts. We are having the last compound according to our syllabus, that is plaster of Paris. Now what is this plaster of Paris? All of you have heard this name because this is a very common thing. You have seen it when a person get fractured his legs or hand. What will happen? एक प्लास्टर लगता है उसको प्लास्टर किया जाता है so that कि बोन उसका proper position में आ जाए. तो that is actually the plaster of Paris that doctors use to just bind that broken bones of legs and hands. Now, when we are coming to the chemical aspect of this plaster of Paris, here we have certain things like its chemical name, its chemical formula. This plaster of Paris is first of all popularly named as POP. So student, whenever there is POP is written, you have to remember that it is plaster of Paris. Now its chemical name is calcium sulfate hemihydrate, having the formula CaSO4 dot half H2O. So this is the formula of calcium sulfate hemihydrate, that is plaster of Paris, CaSO4 dot half H2O. So it contains half water molecules. Now, when we are watching the preparation of this compound, students, here I want to notify that the previous compounds this compound is different from the previous compound that we have read. In the previous compound, we read the preparation method from the brine, that is sodium chloride. But here, this POP is prepared from a compound named as gypsum. So when we are watching the preparation method of plaster of Paris, we are having the reaction of gypsum. Gypsum is what? It is actually calcium sulfate dihydrate. Means what? Calcium sulfate when mixed with two molecules of water, we get gypsum. So for preparing the plaster of Paris, we just heat this gypsum at 373 Kelvin. Here you have to remember that this temperature is very important. If we heat gypsum at this much of temperature, then only we get the POP with the release of 1/1/2 water molecule. Now, when we heat this gypsum above 373 Kelvin, then what will happen? Definitely all the water molecule will evaporate. किसी भी चीज को हम हीट करते हैं तो वाटर एवापोरेट होता है. एग्जैक्टली 373 केल्विन पे अगर हम हीट कर रहे हैं तो हाफ मॉलिक्यूल रिमेनिंग रहेगा जिप्सम का, बाकी सारा इवापोरेट हो जाएगा. इफ हाफ मॉलिक्यूल इज देयर, इट इज पीओपी. बट अगर हम इसको 373 से ज्यादा पे हीट करते रहते हैं, व्हेन वी इंक्रीज द टेम्परेचर बियॉन्ड 373 केल्विन, देन व्हाट विल हैपन? वी विल गेट एनहाइड्रस calcium sulfate. Now this anhydrous calcium sulfate having no any water molecule is called as dead burnt plaster. So students, in MCQ question this can be asked as a question that what is dead burnt plaster. So do remember, anhydrous calcium sulfate is known as dead burnt plaster. So if you are writing the preparation method or the reaction of manufacturing of plaster of Paris, you are supposed to write the specified temperature, because if you have not written the temperature, it may be possible that anhydrous calcium sulfate will form instead of plaster of Paris. So for preparing it, gypsum is heated at 373 Kelvin. We get POP with the release of 3/2 water molecules. Now, when we are watching the properties after the preparation, the next thing which we are having is the properties of plaster of Paris. So if we are talking about the color and state, already you have seen the plaster of Paris. Its color is white and its state is powder. Students, in the previous lectures, I had described you that solid state exists in two forms. First is crystalline, second is amorphous. Crystalline means sand-like appearance, rough touch, and amorphous means powdery touch, smooth appearance. So this plaster of Paris is powdered in nature. So the color is white and state is powder. The second property is reaction with water. So when we react this POP with water, what will happen? Definitely, when we add water to something, it becomes rehydrated. So when POP rehydrated, it again become gypsum, a solid mass, a gypsum. So this reaction is reversible. When we heat gypsum, we will get POP. When we add water to the POP, we can get the gypsum again. So here is the reaction. When mixed with water and left for half an hour, it sets to hard mass due to rehydration of POP to gypsum, and the reaction is CaSO4 dot half H2O plus 1/2 H2O. It gives CaSO4 dot 2 H2O, which is the formula of gypsum. So students, do remember that when we heat gypsum, we can get POP. When we add water to the POP, we can again get the gypsum. So there are only two properties of POP which you have to study. First is its color and state, and the second is its reaction with water. Now let's have a look on the uses of plaster of Paris. Now let's have a look on the uses. But before that, students, I want to remind one thing. That is, just now we have discussed that when we add water to the POP, it gets back to the gypsum. But we have read about the term dead burnt plaster when we are learning the preparation method of POP. So dead burnt plaster is actually anhydrous calcium sulfate. Actually, why it is called as dead burnt plaster? The reason behind it is when we add water to this, we are not going to have the POP or gypsum again. That's why the chemist named it as dead burnt plaster. So it might be coming your mind that, ma'am, it is possible that if we add water to the calcium sulfate, it becomes POP again. When we add water to the calcium sulfate, it becomes gypsum again. But the thing is, it is not so. This is the property of POP only, that when we add water to POP, it gets back to gypsum. But when we add water to this CaSO4 and anhydrous CaSO4, we are not going to have the POP or the gypsum again. That's why it is called as dead burnt plaster. So this is a very noticeable point. So students, do remember this thing. Now let's have a look on the uses of plaster of Paris. It has lots of uses in our day-to-day life. It is very common for us. We have seen it because there are a vital role of it. The very first is in the medical science. In the medical science, this POP is used for setting fractured bones to its right position. Now the second one is in making toys, statues or decorative material. Many of you have seen various decorative pieces made up of POP. बहुत सारा सो पीसेस आता है जो कि सीमेंट फॉर्म में दिखता है, आपको लगता है कि सीमेंट का बना हुआ है और उस पे आप किसी ने कलरिंग की है, बट एक्चुअली वो कभी सीमेंट नहीं होता है. दैट इज एक्चुअली पीओपी. सो द सेकेंड यूज इज इट इज यूज्ड इन मेकिंग टॉयज, statues, decorative material, etc. Third one is in making the surface smooth like walls, ceiling before paints. पेंट करने से पहले घर पे आप देखते होंगे कि एक पेस्ट लगाते हैं पेंटर्स. दैट इज बिकॉज कि सरफेस पूरा स्मूथ हो जाए. तो वो जो स्मूथ करने के लिए जो मटेरियल पेंटर्स यूज करते हैं, दैट इज एक्चुअली पीओपी. नाउ द नेक्स्ट यूज इज इन मेकिंग chalk for writing on board. You have seen chalk in your schools. All those chalks are also made up of plaster of Paris. It can be used for that. Next is to beautify the house by making decorative designs on ceilings and pillars. You have seen it in your homes or in various offices and in schools also. The ceilings are decorative. सीलिंग पे बहुत सारी डिजाइनिंग या कार्निशिंग की हुई रहती है. वो सारा डिजाइनिंग एंड कार्निशिंग दैट इज मेड अप ऑफ पीओपी ओनली. Next is in making fireproof materials. So for making the thing fireproof, we use this POP. And the last one is in the laboratory. What is the role of this POP in the laboratory? So we use this POP in the laboratory for making airtight containers or apparatus by sealing the gaps. अगर हमने कॉनिकल फ्लास्क लिया, उसके ऊपर स्टॉपर लगा दिया है और उसके बावजूद भी एयर स्पेसेस है, तो उसको सील करने के लिए अगर हमें कोई ऐसा कंटेनर चाहिए जिसको हमको एयर टाइट रखना है, तो फॉर सीलिंग दैट गैप्स ऑल्सो वी यूज द पीओपी. So these are the uses of POP in medical science, in homes, for making our houses, in laboratory. In many fields, they have a vital role. That's why it is a very important compound for us. Now let's have a look on the last topic of this chapter, that is water of crystallization. Now what is this water of crystallization? If we have seen the previous compound like plaster of Paris, it has the formula CaSO4 dot half H2O, gypsum CaSO4 dot 2H2O, copper sulfate CuSO4 dot 5H2O. So what is this dot half H2O dot 2H2O dot 5H2O? This is actually the water of crystallization. So if you are going to study the water of crystallization, the one thing is which you have to question in your mind, that are the salts are really dry? Because all the salts, maximum salts, have some quantity of water molecules because they are the crystals. So they need the water molecule to form the crystallization, to form the crystals. But students, here you have to keep this thing in your mind, that every salt is not having the water of crystallization. So if we are having this question that if the salts are really dry or not, for this we can conduct one experiment. If you have gone through the experimental video uploaded by me, you have seen the decomposition. During the decomposition reaction, I have shown the heating of copper sulfate, hydrated copper sulfate, which is blue in color. So let's assume an experiment. You can see that experiment in my video also, experimental video which I have uploaded earlier. Then that when we heat the copper sulfate, we are having CuSO4 dot 5H2O. This is hydrated copper sulfate. So if this is the thing, if CuSO4 dot 5H2O. This is actually the copper sulfate, hydrated copper sulfate, which is blue in color. So when we heat it, it becomes anhydrous copper sulfate having no any water molecule. All the water molecule will be evaporated and we get the white copper sulfate. Here, when we add water to this copper sulfate, we are going to get back this blue hydrated copper sulfate. So student, why we are discussing this reaction? It is because we are here to have the answer of the question, is the salts are really dry or not? Salts dry होते हैं या नहीं? अगर ये क्वेश्चन आपके दिमाग में आता है तो ये एक्सपेरिमेंट आप उस चीज को प्रूव कर देता है. हमने एक एक्सपेरिमेंट में बात की थी डिकम्पोजिशन रिएक्शन के बारे में, जिसमें हमने चर्चा की थी कि अगर हम टेस्ट ट्यूब में हाइड्रेटेड कॉपर सल्फेट लेते हैं जो कि ब्लू कलर का होता है, उसको हम हीट करते हैं तो हमने टेस्ट ट्यूब के सरफेस पे वाटर मॉलिक्यूल ऑब्जर्व किया था. तो हमने तो ड्राई ही लिया था अपने हिसाब से, हमने वाटर ऐड नहीं किया था, बट स्टिल वी कैन ऑब्जर्व द वाटर वेपर ऑन द सरफेस ऑफ द टेस्ट ट्यूब. जो क्या दर्शा रहा है, जो क्या चीज दिखा रहा है, वो इस चीज को शो कर रहा है कि वो ड्राई, जो सॉल्ट ड्राई दिखता भी है, इट इज नॉट नेसेसरी कि वो ड्राई है ही, उसमें कुछ ना कुछ वाटर मॉलिक्यूल हो सकता है कि प्रेजेंट हो. वो जो वाटर मॉलिक्यूल है, दैट इज एक्चुअली द वाटर ऑफ crystallization. So when we are going to define the water of crystallization, how can we define? It is the fixed number of water molecule present in one formula unit of salt. It is the fixed number of water molecule present in one formula unit of the salt. This is called as water of crystallization. As for example, if we take this copper sulfate, so it is having the formula CuSO4 dot 5H2O. So this 5 is the water of crystallization for this copper sulfate. Similarly, CaSO4 dot half H2O. So this half is the water of crystallization for plaster of Paris. CaSO4 dot 2H2O. So this 2 is the water of crystallization for gypsum. and so on. So the amount of water, the fixed number of water molecule present in the formula unit of a substance, of a compound, of a salt is called as water of crystallization. So students, do remember, it is not necessary that the salts are always dry. So we can have this point then that salts can exist in two forms. Salts can have the two forms. First is anhydrous, means no any water molecule, or you can write the salts which is not having the water of crystallization are called as anhydrous salts. Anhydrated salts means that contains water molecule. So if the salt contains the water molecule, it becomes hydrated. So based on water of crystallization, we can classify the salts into two forms. One is anhydrous, other is hydrated. So students, this is the last topic of our chapter, acid, bases and salts. Hope you have understood it very well. If you are having any doubt, any query regarding any of the topic of this chapter, you can ask in the comment box. Here, I want to notify one more thing. Now, you are having your revised syllabus from CBSE. In the revised syllabus also, acid, bases, salts is complete. There is no any cut from this chapter. So, you have to read each and every topic very carefully. So, be ready for the next chapter, metals and non-metals, which I am going to upload in the next video. Thank you.